Avinash Khare will briefly overview us about scope of digitalization in stamping.
Something that industry is already doing. These are something which are futuristic and they have to be done when somebody is going for industry 4, particularly in stamping industry. See, many things which we talk in industry 4, commonly like OEE, productivity, scheduling, condition-based maintenance. Now, all these things we have been doing, 2 decades back also when there was no industry 4 and there was no digitization and digitalization. I am focusing on 5 aspects, only 5 aspects, short and crisp, 5 aspects of where specifically for stamping industry, digitalization will work wonders. So the agenda of my talk is first area which is likely to be affected is the simulation, or in industry 4 we call it virtual twin. Okay, the concept of virtual twin where you can simulate right up to defects and cost and whatnot, everything. Now, so far there is formability simulation done all right, but beyond that a lot remains to be done. So we'll be dwelling on what all could be integrated in this virtual twin concept as far as simulation in soft stage is concerned. Second is adaptive correction of any variations which may be there in material, equipment, process, ambient conditions, etc. So adaptive control built into stamping dies. Third aspect that I'm talking is process monitoring while stamping. You can't inspect each and every job. It is mass production, 15 parts a minute types, right? So it's difficult to handle, let alone inspect individual parts. And it's very easy to mass produce a heap of defects. Before anybody finds out something is going wrong, you would have produced a mountain of scrap, right? So how to prevent that going further, going the digital way? So process monitoring while stamping. And then the stamping industry, press lines are very capital intensive, they are very expensive. And there is a need to do single minute exchange of dies, SMED. Now this term SMED has been hijacked by management gurus and they have diverted it to different direction as a management buzzword. But technically how literal SMED can be done, and in literal 1 minute, how can one exchange from one part to another part on the press line? So that is the fourth aspect. And fifth aspect is, of course, how do you increase the speed and through automation? What are the issues and how does one overcome? So these are just the 5 things that I'm going to talk. Okay. So presently, our industries in stamping are doing standalone formability simulation, which is an ivory tower by itself. Somebody sits and does techno astrology, sitting there and predicts something. And what happens is something quite different end of the day, because they have not considered the effect of imperfections in dies, imperfections in presses, imperfections in automation, and variation in the supplies, whatever comes. So FE based simulation is done formability. It does predict things like defects related to thinning, wrinkling, cracks, movement of trim lines, spring back. But the use is rather limited, mostly only to draw and crack forming operations. Not for bending, not so much for cutting, not so much for other things, not for the complete process so much. And simulation is generally also used for, as my friend was talking earlier, for nesting and cost comparison and how to improve the material yield, etc. And mostly in simulation, they use a CAD model. There is a part CAD model. Parallel to that, you generate the die surfaces, which are parallel, and you move them in a straight line at constant speed, assuming that that's how the press will move, which does not happen that way, by the way. So according to the theoretical surface design, you are assuming everything to be in ideal condition. Okay. And what is not considered is that the brute force which the press is applying, there is a severe deflection in the press bed, in the press slide. Okay. There is deflection of much bigger order than what is the quality requirement, right, from the process. So, and some other things that they are not able to predict. So all that hammering action is not simulated because nobody has digitized the equipment. No, the software does not know how much is the play, how much is the mass, how much is the deflection. So all that is not done. Plus, when the upper die is coming with the cavity, it is coming at a high velocity, is gathering a lot of wind. Now that is interfering with the forming. So all these effects are not getting considered in the simulation the way it is being done currently. Now, if you want it to be a complete, perfect virtual twin, as it is envisaged in Industry 4, then we better start integrating all these things. Okay. So virtual twin concept, if it has to be fully deployed, you have to digitize some things on press, something on die behavior, and integrate it with simulation so that the prediction is very accurate. So imperfection in press meaning deviation from parallelism, deflection in table, deflection in RAM, the kinematics, the height versus velocity, the cushion behavior. Now, all these things are never getting considered in simulation so far. Okay. So now going to the finer aspects of things. You imagine a die kept on a press bed. Now, press bed is hollow underneath. It is only supported on edges because below there is a cushion pad. So there cannot be a support throughout to the press bed. So press bed, which is having, let us say, 1,000-ton force, 2,000, 3,000-ton force, this is going to buckle. So there will be a sag. Now there can be two cases. If the die is over designed, it is too sturdy, the table will deflect, the table will bow, but the die will not. In other words, the die will be floating on edges. It will be slipping on the edges. So stroke to stroke, there is likelihood of die shifting, the lower die shifting. So first part may come all right, 10th part may be a disaster. Now these kind of things are practically seen in the field. Okay. But unless you simulate this aspect, you will not come to know that this is going to happen practically. Right. Other cases, other extreme, that the die is made so delicate that it is bending along with the press bed. Okay. Now here, if you see underneath, you will see some light. A feeler can go under the die. Here nothing can go because the whole die is bending along with the table. Okay. Which means that deliberately, as per your design standard, it has, the bank holder has to be made flexible so that it will have the full bearing in spite of deflection, and in spite of deflection, it will produce a good part. Now that is the art and science of bedding the die, so-called bedding the die. But it has to be practically done on production press. You have to take the die, you have to take the impression, and practically you do scraping until you bed the die perfectly, and there is a mating in spite of deflection, in spite of full tonnage, right? But that is not being simulated. That is something which has to be done the hard way, okay, by handwork on the costly tryout press, not tryout press, production press line. So for testing one die, you are holding up the 5 presses on the press line. So that is something which is simply not affordable, right? Now, press makers are doing some kind of FE simulations like this one, for example. Okay. Now, dies, even as there is CAD model available for the die, nowadays everybody works from CAD model, but the simulation is not being done. FE simulation, doing FE simulation and integrating it with the simulation of formability and press. This integration is the missing link. Okay. So this is something which is required to be done if you want to make it a perfect virtual twin system, where you can predict everything, the fineness of the quality, etc., in spite of all the variables. Another thing is that we like it or not, there are so many variables in the process. The material properties, the lubrication quality, the deflection of the press, the velocity of the press, the wind gathering inside the press, and so on. There are so many things. So, however perfect your prediction may be, techno-astrology may be, eventually there is going to be some gap, and which is going to be painful for the shop people. So, there is always a scope of making adaptive control in the dies. The die should adjust to the variation. Okay. Everything does not happen as planned. Let us accept it. Okay. Now the technology is there. For example, this is a hydro cam which is there in the die. You see there is a short hydraulic cylinder. The press comes down, it builds up pressure, and that pressure operates a cam. Okay. The same technology is used here for a different purpose. Here there are two drawbeads, one ordinary drawbead and one adaptive draw bead. Now what this does is that after the forming is done, the bead is getting lifted hydraulically so that it pulls the material and it tightens the material on this corner so that it kills the spring back. You see this side has not sprung back, this side is sprung back severely, right? Now the same technology, now that we say that hydraulics is there, servo hydraulics can be there in the die as. Now third part is what I was saying, that if you are hitting number of parts at 15 parts a minute, if something goes wrong, by the time you know that something is going wrong, you would have produced 100 parts. What do you do with those 100 parts? So it is said that in olden times, our skilled operator used to listen to the sound of stroke and they could decipher if it is an okay stroke or it is abnormal stroke. Now the same technology you can put, nowadays there are sensors available which can record the vibration and sound. And these sensors can be mounted on a magnetic base. They come with a battery and they can talk to your computer on Wi-Fi, wireless. There's no wire to be connected. Can be stuck anywhere on die or press. It's so simple, right? It can record. Now, suppose you have produced 100 OK parts and you have recorded the vibration pattern versus time. Okay, the vibration pattern meaning in time domain as well as frequency spectrum domain. Whatever you are supposed to get for an OK part, you study for 100 parts, then you decide your OK signature. And subsequently, you monitor each and every stroke. If anything is deviating significantly from your signature, you can raise a flag that something is wrong. Simple. Now, this is called process monitoring while stamping. Now, with industry, what has become important is, in view of high cost of press line, is to change from part A to part B very fast. Now, real SMAD, literal SMAD, single minute exchange of dies. I am not talking of management buzzword. I am talking of single minute exchange of die physically on the press. Okay. Now, if you have to do it, suppose each die comes with an RFID tag and the press has RFID reader. Okay. So it knows what is the next part. So the PLC can automatically do the settings according to the next part, so that somebody does not have to do the settings manually. Okay. Setting according to the next part could be very well automated by sensing the ID of the next die. Okay. And the idea for single minute exchange of die is very simple. I'll talk in pictures. You can read the text later. Probably. Now, this is how the press line will look like. So you have two tables, each press has two tables. Okay. One remains out, one remains in all the time. So the one which is out, you put the next die there, next set of dies there. Okay. Whenever a changeover is there, older set of dies rolls out and the next set of die rolls in from other side directly. Okay. Now this is one change. Since it is ready in advance offline, the change can happen very fast. Okay. That is one. Second part is, of course, when the part is changed, the gripper has to be changed. So the gripper can be parked on the stand and next gripper can be picked up by the robots. So it can be so fast that you keep this gripper, take the next gripper, where the die is loaded with the crane and gets self-located very easily. So you don't have to spend time in locating the die. It gets clamped automatically. It gets aligned with these T-slots where it can get clamped automatically or semi-automatically or whatever, right? And lastly, the robo has to do this function. Now, ideally, the press line never stops. So the upper die will always be moving. The robo from the next press has to come, has to pick up the part from the previous die, move it to the next die. You see the upper die is not stopping anywhere. And from the previous press, next robo comes. It has to keep the next part. And you see it escapes with a whisker. Otherwise, robo will get crushed in the die. Right? It is optimized to this level. But when you change the die, when you change the part, you have to obviously change these automation pathways, these blue lines, which the robots are supposed to follow. Now, if you know the ID of the die, if you know the ID of next part, you can advise the robot to switch from program X to program Y. Very easy, simple. And that can be done very fast. And you avoid things like cushion pins, changing cushion pins, because you go for nitrogen spring in the lower die, so that you don't depend too much on the press. So on physically on the press, nothing much has to be changed. Okay. So everything else can be done. Practically, there are issues. I'll show you visually what are the issues. When you increase the speed, you see the sheet keeps oscillating. The faster you accelerate and stop, okay, there will be oscillations and you have to wait for oscillations. So until the oscillations die down, you cannot keep it in the die. So whatever you achieve by increasing the speed gets sacrificed in waiting for oscillations to die down, right? Now that's the problem. But nowadays there are of course piezo mounts where you can actively kill the vibration, So you teach in those sensors and you can negate the vibration as shown in this one. Sorry. Now active compensation is off now. You can see how much these handles are shaking. While accelerating and braking, how much these knobs are moving. But when you switch it on, now you see the vibrations are getting killed. So active killing of vibration in automation is another area where digitalization will work wonders. Okay, that's all from me. Thanks for your attention.
For sharing and highlighting the significance of stamping.